Welcome back, welcome back, welcome back. I'm Lisa Blackburn, and this is my YouTube channel where I talk about everything I want to, science and math. And today, this is physical science class, and this is Unit 2, and we're going to talk about properties of the atom and the periodic table. They're laughing. I have like over 400 subscribers and over 20,000 views.
No, I have 1,000 on TikTok.
Who does?
No one cares.
That's pretty good. That's pretty good. All right, and I want more subscribers because if I get 1,000, I don't have to videotape it then upload it. I can do like I used to on Facebook, and it'll go on it. So that's why I have a goal. My actual children that say, "Mom, nah, it's not gonna happen. You're never gonna get from 400 to 1,000, but I can dream, right?" All right, so this is Unit 2. And so we're going to be talking about the periodic table. I'm going to be pulling those papers down, and we're going to learn about atoms and the periodic table, okay? So scientific shorthand. Scientists need to be able to communicate with scientists all over the world. Even though they speak different languages. And we do that through the periodic table. The periodic table is the same all over the world. We write chemical reactions the same all over the world because we all agreed all over the world that's what we're going to use. And we do that. So like my son Nathan, when he was in college, in grad school, he will go online, like YouTube kind of stuff, and there'll be lectures of people in China and India talking about chemistry. He does not understand one word they're saying, but what they write on the board, he understands. And he can watch those videos and figure out what he needs to learn. He doesn't need to understand one word they say because he can understand the math they write down, and he can understand the elements they write down from the periodic table. So how do we do this? The periodic table is the same all over the world. And the periodic table lists the elements which are pure substances. So like gold is only made of gold. It's a pure substance. It's on the periodic table. Water is made of H2O, hydrogen and oxygen. It's not a pure substance. It's not on the periodic table. So we have our little angel on y'all's notes to represent the pure substances. The pure substances can't be broken down and still have their properties. You can break down elements, but if you do, they're only protons, neutrons, and electrons, which are the same. The smallest particle you can get, and it have its properties, like if it's gold, shiny, and yellow, is an atom. Any smaller than an atom, it doesn't have properties anymore. They're all the same. All right. On the periodic table, each has a symbol made of an uppercase letter, and sometimes they also have a lowercase letter. And as you learned when you memorized your elements, not all of them have the lowercase letter. Like carbon is just the uppercase. You have to follow this etiquette, or else I'll take off. Don't write, say if you're doing radon, you wouldn't do RN like that. I will count off for that. It has to be uppercase, lowercase. Any questions about that? I won't take off on your test though, because I hadn't taught it to you yet. Okay, the next one, so some examples. Hydrogen is just one letter. Helium is a big H and a lowercase e. Gold is big A, lowercase u. And y'all had a test on those, so you know about them. The next one is the regions of the periodic table. The center of the atom, do y'all know this from your previous learning? What's the center called? Starts with the N. Nucleus, yes, it's nucleus. N-U-C-L-E-U-S, nucleus. And it's Latin for little nut. So we have a little acorn there being the little nut, the nucleus. It is surrounded by electron clouds. So we have a cloud. The electrons hang out in clouds around it. And we have a little picture of the atom. It's not exactly right. This is the planetary model. I always think of it as the Jimmy Neutron model, but this would be the nucleus, and those would be the clouds. Okay? Now, what are atoms made out of? They're made out of subatomic components. Oops, sorry about that. How far can I go up? Can I go to nucleus? Yeah? Also, these will be online, so you'll be, if you needed it. Okay, atomic components. They are made of protons, neutrons, and electrons. Do you remember learning that in 8th grade physical science? You had physical science in 8th grade, right? And you should have learned about protons, neutrons, and electrons. What charge does protons have? Positive. And you can remember that because positive and proton both start with the letter P. Everybody got that in your head? Protons are positive. Okay, next are neutrons. Now this is where it gets tricky. What charge does neutrons have? Neutral. Because neutral and neutrons both start with N.
Please excuse the interruption. Can I please have Austin Gus to the front office? Austin Gus, please report to the front.
We don't have him. All right. It has no charge. So neutron and neutral both start with the letter N. But electrons are what charge? Negative. So don't get it confused. Electrons are negative. And how I remember that is I make a negative sign and then go around, and it almost looks like an E, doesn't it? So I think of a lowercase e almost looks like a negative in a circle. So when I was learning this, I was concussed. I told you about that, right? About the big horse accident and getting concussed. I had a very hard time. I had a bad concussion. Nowadays, they would just send me home for a year. But this was the dark ages of the 80s, and they didn't know and sent me to school anyway. And I had the hardest time learning anything science or math. So I had to make up little ways to help me learn. A bad horse accident. We'll talk about it later. I'll tell you the story because it still hurts to think about it. All right. Protons are positive, and they are in the nucleus. So protons are in the nucleus. Neutrons with no charge are in the nucleus. And electrons are in the clouds. Now, the protons we have there, see how it looks all positive and smiley and it's big? That's our proton. Our neutron is also big and it's a neutral face. Okay, and it's also big and in the nucleus. Electrons are little bitty. So I drew it little, and I drew it with little angry eyebrows because it's negative. Now, so I want you to know that protons and neutrons are big, electrons are little, and also the symbol for proton is lowercase p, the symbol for neutron is lowercase n, and the symbol for electron is lowercase e. Do we feel good about that? Can we remember that? And you already learned it one time when you were in 8th grade. There are other subatomic particles like quarks, mesons, gluons. There's all kinds of things, but we're not going to learn about it in this class. If you take physics later in high school or college, you don't have to, because this class fulfills your physics requirement for graduation, because we're going to do physics later. But if you do decide to take it later, you can learn about those subatomic particles. Okay? If an atom has no charge, then the number of protons and electrons are equal. If it has no charge, the protons and electrons are equal, and it's sometimes called an atom. It'll say, does it have a charge? People say, no, it's an atom. To me, they're all atoms, but it is some terminology we use sometimes. All right, atomic number. The atomic number is the number of protons. The atomic number is the number of protons. I'm using my symbols here. The atomic number is the number of protons, and it's what makes an element that element. If you look on my periodic table, y'all have to have good eyes because the good one's covered up right now. There's a little blue whole number on each one. This one's 1, that one's 3, that one's 4. That's the number of protons, which is the atomic number. The protons is the atomic number. It's the whole number on the periodic table. How do we feel about that? Are we good with that?
We did that on reports, so
Yes, y'all did that on the reports. Y'all told what the protons were. Okay, can I scroll up to the next page? Okay, for example, carbon's number is 6, so it has 6 protons, and its atomic number is 6. Neon has a number 10 on it, so it has 10 protons, and its atomic number is 10. Hydrogen is number 1. We talked about that with SpongeBob. Hydrogen has 1 proton, so its atomic number is 1. Are we good with that idea? There'll be some test questions like that. That's not too hard, is it? Okay. The atomic weight. Electrons are so small we don't count them in the weight. We don't count them in the mass. The mass is the number of protons plus the number of neutrons. Mass is protons plus neutrons. We don't count electrons, they're too small. Electrons can basically turn themselves into light. And you can't weigh light, can you? They're too little. They're electricity. How do you weigh electricity? All right, we've only got 2 minutes left, and this is a good little stopping point. Tomorrow we're going to see a video that will help us with the test on Monday over the properties. And I'm going to put on Canvas a Quizlet to help you study. Science is great.